Hello and welcome to Less Code, More Services, Better Android Apps. Thanks so much for coming. I know we had a lot of great sessions to choose from, so we're both honored that you're coming to ours. My name is Manfred. I'm a product manager working at the intersection of Android Studio and Google Cloud.
And I'm Jatin. I'm an Android engineer working on sync and authentication. And one of my really good passions is basically having seamless transition of users across multiple devices.
And that is actually particularly important in today's multi-device world. So it doesn't matter if you're writing an Android game or a simple task management app, your users are expecting their data to be persisted across multiple devices and to be accessed from anywhere. So in this session, we're going to show you how to build mobile apps which use both new and existing Google technologies to simplify cloud data storage, online-offline interaction, and synchronization across multiple devices. Throughout the session, you'll see how Android Studio tooling makes these tasks straightforward and allows you to bring the full power of Google Cloud Platform to your apps. So we hope that you're going to come away equipped with new tools and new skills to make your Android apps better than ever without having to write hundreds of lines of code. So the fact is that most of the interesting applications nowadays are powered by cloud. According to EDC research, around 83% of mobile app developers last year were planning to execute some code on the cloud. And as early as in 2012, already 63% of app developers were using some sort of cloud storage APIs. Now, the main reason for that is because we're all developers. And we want to make our applications more engaging. And this might involve using some data that's changing rapidly. So think about weather, or in my case, think about today's basketball scores. Or you might want to store some data that's just simply too large to store on the device. So think about a sample of every song in the world, right? Like, it's not going to fit on the device. And then we also want to make the data synchronized across all of the devices that your users might have. So it might be a phone, a tablet, and if I add a task into a task management app on my phone, I want the same task to be available on the tablet as well, right? So when you get one of these crazy and exciting ideas, you want to focus on the core idea. You don't want to worry about servers, load balancer configurations, content distribution networks, and so on, right? Now, the good thing is that a lot of this complexity is handled for you by Google Cloud Endpoints, which allow you to build powerful backend APIs in a very simple way. So you can use familiar tools and skills, like Android Studio and Java, to develop not only your Android apps, but the backends for them as well. And you can start communicating with your app really, really easily by calling the client libraries which are produced for your backend from the Android app. And then finally, as your application grows, your backend is also going to scale automatically because under the hood, it's actually powered by Google App Engine, which comes with its own auto-scaling and high availability guarantees. So here's the typical architecture of a Cloud Endpoints powered app. On the right-hand side, you have the backend, which is running on Google App Engine. And then on the left-hand side, you have the clients, which might be JavaScript, Android, iOS. And these clients are using Cloud Endpoint client libraries to communicate with the backend. So this might seem a little bit complicated from the first sight. But in reality, Cloud Endpoints define a very simple workflow. So you start by writing the endpoint, which is the actual code which you want to run in the backend. And essentially, all that it is, it's a simple Java class with a couple of annotations. So here I have my endpoint class, and towards the middle of the snippet, I have a method, say hi. It takes a string name, and it returns the response hi name. Very simple. Now, I annotate my endpoint class with an API annotation. So I give it the name my API. And then similarly, I give the annotation to the method, which I want to run in the backend. And I give it the name say hi. So my API, say hi. Once that is done, I can literally just deploy this Java class to Google App Engine backend. And by the way, I don't have to worry about things like spinning up App Engine instances and things like that. Google Cloud Endpoints take care of all of that for me. I deploy that to the backend, and it starts running on Google's infrastructure. And then finally, once that is done, you can start calling the strongly typed, mobile-optimized client libraries from your mobile app, which are derived from these annotations, which you just put in the code. So here's the same example. If you remember, I gave the API name my API and method say hi. And this is a screenshot from Android Studio, where you can see a my API object exposed, which has a say hi method. All of these libraries, which I can call from Android client, were generated just from those simple annotations. So at this point, I'm actually going to hand it over to Jatin, who's going to give us a simple example of how to add the backend like that from Android Studio.
All right. I already have Android Studio open with my project in there. And what I'm going to do is add a backend to this. It is going to be simple, a couple of steps. And then after that, I'm going to run this, run a server locally, and then hit it with a browser and show you that you can actually hit it and what you can do with it during debug phases. So let's go and click here, say new module. Select endpoints module, say next. Let's name our backend. Pretty original. All right, so what you can see here is that it created a folder named backend, and it has the exact same classes which Manfred just mentioned. So you can see my endpoints here, and it's basically the endpoint which we are going to show you. And it uses something called myBean, which is a bean. And this bean is used for sending data between the client and the server. So let me quickly run this. If we click run, it's going to start off a server here. If you look at the Gradle file, OK, there you go. And we're going to hit localhost 8080. This server is already up now.
Cool.
So what you see here is an index.html file, which was auto-generated for our my endpoints. And if we write in IO session here and say hello, the server is going to respond with hi IO session, which is the response which server was supposed to give us. Now, one of the awesome parts over here is if you look at this little tab, it's called Endpoints API Explorer. If you click through it, it's going to take you to a dashboard, which is going to show you all the APIs present on your server. You can see my API over here, and if you click through this, it'll list you all the methods your API has. In this case, it's say hi. If you click through that, you'll see a form there. This form is used to create a request right from your web browser. And let's enter Manfred's name here and execute. So the server is going to return hi Manfred. But if you look at the bottom half of the screen, you can see the exact request which was sent to the server and the exact response the server sent back. And you can see how it was structured, which is really important if you need to debug something in your server. So let's see if we can actually have a demo here, like an example.
Yeah, I mean, by all means, let's do an example. So we're going to show you how to use Cloud Endpoints in your actual app to make it a bit more engaging. So some of you might have seen this app at the keynote earlier yesterday. Essentially, it's a very simple Android app which lets me to record my path, distance, speed, elevation as I run, jog, bike, do anything else outdoors. And in the screenshot, you can see one of my walks earlier today around the Google campus. While the app is pretty cool already, me and Jatin had a few good ideas on how we could make it a bit more engaging. So here's one. When I go for a jog, I often get bored by always taking the same route. Wouldn't it be cool if when I clicked on the track button down right in the corner, it would show me an interesting location within my jogging radius so that I could get both fit and see something new? Something like that, right? So Jatin, how would one go about putting together an endpoints backend which does something like this?
Sure, I can show it to you in a minute. So I already have this project open here, and we already did some changes to the my endpoints API to return us the correct response we wanted. So I'll walk you through the code the changes which we made. So let's look at the server-side code first. So if you remember, we had the class named myEndpoints. We renamed it to suggest API endpoint. Now within this, we changed the name of the API to suggest instead of my API. And we renamed the name, the method name to destination. Now this method takes in two variables, two parameters, the latitude and the longitude. And what we are going to do here is that take these two latitude and longitudes and figure out a random point nearby and return that. And along with that, we're going to slap on a quick description about what that point is. And we picked that from one of the 3 static description we have. So if you notice, we also changed the bean here. We just renamed it to destination bean, and we added a few more data to it. So if you click through it, the bean contains the new latitude and longitude along with a description. So once the server sends back this bean, the client will receive the bean, and the client stub is going to give this bean back to your application. Now let's look at the changes we made in the application code. So we added a new class called endpoints async task, which is an asynchronous async task provided by Android. And in the constructor of this class, we created a stub for our API. If you remember, we named the API as suggest. So the stub which was created is also named suggest. And once we have the stub, here we call the method destination on it, pass it the current latitude and longitude of the device, and we call execute. So the execute method returns us the destination bean returned from the server. And this is what is returned back from the class. And the UI takes care of looking at this bean and displaying it on our device. So let's quickly run this on our device. So I'm going to click play here, which is going to compile the code and ship it to my device, which is right here. So let's switch over to the projector. So the app should soon come up over here as soon as the compilation is done and it pushes the app. There you go. All right. So we are near Mission and Fourth in Moscone Center here. OK. So we're going to hit the track button, and this is supposed to go and hit our server. The server is going to respond back with an interesting destination nearby. There you go. If we zoom out, there it is. Oh, the world's deepest rabbit hole.
Wow, cool. All right, this is a good time to clap, guys. All right, thanks, Jatin. So the keenest of you can actually try to deduce the probability of what were the chances to get the same message. And it was 1 out of 3 because we had 3 static descriptions. All right, so let me move on. Let me just quickly summarize what we've seen so far in the session. So you've seen that Jatin used Java plus Android Studio to write the code both for the backend and for his Android app. And then you've seen that Cloud Endpoints took care of almost all of the plumbing. So object serialization, deserialization, compression, encryption using SSL, generating client libraries, all of that was taken care of by Cloud Endpoints. And that's great for us as developers, but it's actually really good for our users as well. So the fact that all of the JSON objects are automatically compressed as they go over the wire means that our apps use minimal amount of networking, which in turn increases the battery life. And similarly, the fact that all data is encoded encrypted using SSL means that your user's information is secure, and so on. So finally, the fact that endpoints backends are deployed on Google App Engine means that your apps stay responsive and available as your user base grows, since your app can actually now take the advantage of Google's infrastructure and Google's data centers across the world. OK, so all of this is pretty cool. But at this point, let me switch gears a bit. There are many cases when you don't actually need to run custom code in the backend to make your applications more engaging. In many cases, all you want to do is to make sure that your app does not suffer from what I call appnesia. And that's basically a disease that causes your app to forget its users. So by the show of hands, how many of you at some point have reinstalled an app and discovered that it forgot something about you? Like user preferences, or might be the game save state? Quite a few of you. So last year, we announced Cloud Save, a game save storage API with the goal of never having your users to have repeat the same level in a game. Now this year, we're very happy to announce a new API for all Android app developers called Google Cloud Save for Android, which makes it really easy to store users' data in the cloud and to synchronize it across all of the users' devices. So this new API is really useful when you want to store some structured data. So it might be some application-specific preferences. Like if I have a stock portfolio app and I want to add the stock ticker, and I want the same stock ticker to be available for the users across all of the devices, you can use Cloud Save. Furthermore, you can actually use it to store any generic structured user data. So tasks in a task management app or planned journeys in a travel planning app. And the really great thing about this new API is that it requires zero backend programming. So all you do is you write the client-side code to store and query data, and then the backend for your app is fully managed by Google. And the other thing that I'm really excited about is we still have access to all of your users' data. So if you want to run some statistical analysis to get a better insight into how your users are using the app, or if you want to run some big data tools like BigQuery to aggregate the data and expose it via some sort of web dashboard, you have full access to it. And then finally, this API is ideally suited for the multi-device world. So as your user's data is saved in the backend, it's automatically synchronized across all of the user's devices. And you don't have to write a single line of code to handle that. So some of you in the audience might actually be worrying that there's going to be a lot of corner cases to handle the offline scenarios. You don't have to worry about that either. Even if the connection is lost as soon as the app is downloaded, it's going to work just fine, and the data is going to be automatically synchronized immediately after your app comes back online, and you won't have to write a single line of code to do that either. So anyway, I think at this point, I might have sold it just enough. I'm going to hand it over back to Jatin, who's going to give you more technical details about Cloud Save.
Thank you, Manfred. So with increasing popularity of Android, users have been buying more and more devices. So nowadays, users have multiple devices. So for example, in this case, if they have a phone and a tablet, then there is an issue here. With standalone apps, you end up either having to figure out how to sync the data across the two, or you will have to deal with having fragmented data across two different devices, which is a pretty sucky user experience. So with Cloud Save, we provide you a solution to synchronize data across multiple devices, and at the same time, have the data be stored in the backend. This allows you to focus on your app and trying to figure out the logic of your app, whereas we take care of all the details regarding synchronization and storing in the cloud. The best part about this is that all this data is stored in your project. It's your developer console project where the data gets stored. So which means that you have full access to this. You have full ownership of the data. What does this mean for you? Well, it means that you can have queries run on this data, or you can have dashboards running on this data. You can expose this data to the user. And when your app becomes really successful, and just in case, if you make a bug and there's a data corruption, oh, bear with me. I know this doesn't happen. But if just in case if it happens, you can go back, have a small App Engine app which runs a MapReduce, and fix the data on the backend. So it basically provides you a wholesome atmosphere with data on your end. Now, in the next few slides, we are going to show you what the API looks like and how to use this. But to do this, we're going to take the help of our Walkshare app as an example and step you through different parts of it. And we'll show you a demo also at the end. Now, before we go into this, let me remind you that Walkshare app stores two types of things. One is the trail on which you walked. And as a part of the trail, there are multiple waypoints. All right? So there's a trail. Waypoints belong to each. A group of waypoints belong to a trail. Now, Cloud Safe, we have something called an entity, which forms the unit of our data structure. And it also forms a unit of sync for us. So for those of you who have already used Datastore from Cloud, this mirrors the Datastore's entity. For those of you who haven't used that, let me show you what it looks like. So an entity has a key. And this key is formed of two parts, a kind and a name. So kind is something like a class. And you can have multiple entities sitting in the same class, like a group. And a name is a unique identifier within this class. So once you have an entity, you can set properties on it. And these properties can have different types from a list of types we support. For example, strings, byte arrays, booleans, and many more. We also support lists, by the way. All right. You can have as many entities as you want and store them, and we encourage you to have smaller entities. Smaller entities make better sync performance, and at the same time, you'll have less amount of conflicts in when you try to save something. So we'll come back to conflicts a little bit later. Before that, I want to show you a little bit other things we provide via Cloud Safe. So we also have built-in user authentication. What does it mean? So all you have to do is let the user select an account that they want to use, and then you just pass that account to us. We take care of authentication. We take care of partitioning your data based on the user, and we make sure that one user cannot access another user's data. And by the way, all this data and the data structure in the backend is already visible to you, so you have full power over it. Now, currently, we only support Google accounts, but in future, we do plan to have more than Google accounts as the authentication systems or authentication providers. So let's talk about where the API exists and how to use it. So we provide Cloud Safe as a part of Google Play Services. And for those of you who have already used Google Play Services, you already know what this is. For those of you who have not used it, let me just give you a brief explanation of what this is. So Google API Client is a stub, or it's a client-side stub, which is provided to you, and it's presented as a part of your app. And it helps you talk to services inside Google Play Services. So all you have to do is create a Google API client using its builder, add the APIs you want to use. So in this particular case, it's cloudsafemanager.api. Then add a scope, add the account which the user selected, and add a few callbacks. Now, an interesting part about Android Studio is that Android Studio sort of creates this boilerplate code for you. So all you got to do is right-click on the app, select Google Play Services activity, and enable Cloud Safe. So if you enable Cloud Safe, it will already create an activity called Google Play Services activity, which has the Google API client already in there, created for you with the correct API. It already has a few callbacks, like a generic callbacks, and it's pretty easy to start off with. We work pretty hard to keep the API simple, and believe me, it's pretty hard to keep things simple. So the reason behind keeping an API simple is that we believe that the simpler the API is, the easier it is for you to use it. So as a part of this API, we provide you a few simple methods, namely save, delete, query, and request sync. So at this point, let me note that request sync is only provided to you so that in case your app needs to provide something like refresh button to your users, then you can use this method via the button. Otherwise, you don't need to think about sync at all. We take care of syncing everything in the backend, in the background, and you don't need to think about when to sync, when not to sync, or anything about it. Just it's provided only if you want to expose this to the user. So let's drill down into one of the APIs. So let's say you want to save some data. So all you have to do is create the list of entities you want to save, then call Cloud Save Manager.save and provided the API client, and also provided the list of entities you want to save, and that's it. It's going to return you a pending result with, and this pending result is like a future object where you can either set a callback. So when the result arrives, the callback will be called, or you can just call a blocking method await, and you can wait for the result to come back. Once you have stored this data, the next thing is you want to read it. So for reading data, we provide a very simple but effective querying API. So as a part of that API, we provide you an object called query, where you can set filters. Now let us see what kind of filters there are. So we provide, so you can set a list of keys as filters. So if you already know what entities you want to fetch and you already have the keys for it, you can just set the keys as in the filters, and it will return you entities belonging to those keys. There's another filter which is you can set kind. So you can say, give me all the entities which belong to this particular kind. So in our case, it can be something like, give me all entities where the kind is waypoints. And then you also have filters based on properties. So you can say, give me all the entities which have property with name equals something and the value equals blah. So let's take an example with respect to Walkshare app. So you have a list of trails, but when you want to display the trail, you click on the trail, and then you need all the waypoints belonging to that trail. So you need to query all the waypoints at that point. So what we can do is, what we have done here is that we created a query object. We set the kind as waypoint, and we set the property as trail ID equals the ID of the trail. And then we call Cloud Save Manager.query. We pass in the API client, and we pass in the query object we just created. This returns a pending result, and as I explained earlier, it's like a future object. So once we have written, we read, but how about conflicts? All of you would already know what conflicts are, but let me give you a quick idea of what's happening here. When you have multiple devices, both of them read the same entity, one tries to write, the server says good, you're good to go. The other tries to write, and the server says, hey, there's a conflict. Now, how do we handle conflicts when they arise? It's simple. We just let you handle it. But in order to do that, we do provide you a lot of help and a lot of structure. So what we have here is something called base event service. You just have to implement this service. And as a part of the service, we provide you a method called onConflict. This method receives 3 parameters, 3 different versions of the same entity which was under conflict. So the first is local, which is the local version which you just wrote. Second is the base, and the third is remote. Remote is the version which the server has. Now, the base entity is basically the least common ancestor of the 2, local and remote, which means that you basically can do a 3-way merge over here. So once you resolve it, you return back the resolved entity, and we take care of storing the resolved entity in the local database. And as soon as it's done, we also sync it across all the devices for you. So you don't have to think about how to sync it, how to store it, and stuff. Now, we tried to keep it as simple as possible. So to do that, we shoved all the boilerplate code inside the base event service. And we also provide you some tools for doing diffs, so that given 2 entities, you can use the tool to get a diff. And after that, we also provide you a simple 3-way merge. So using this, if the conflict is not a complicated conflict, it will resolve it for you. Now, if your app is more complex, and if it needs to have more complex solution for the conflict, then you can do that too, because you already have the 3 different versions. You can do your own 3-way merge. And at the same time, because the resolution is happening at an entity level, you have a pretty good context of what the entity means or what the data is. So it's with that context, you can actually do a much better merge yourself, a much smarter merge. Now, last but not the least, sync optimizations. Because the sync happens in the background, we have the benefit of batching things. So we do try to do that. We try to batch things up so that there's the battery, we have a better performance on battery. We also take care of push notifications for you, which means that whenever there is a change on the server, we'll send a notification to all the devices, and the devices will sync to this new data. We're also aware of Wi-Fi versus cellular network, which means that depending on which network we are on, we'll either go full blast or we can throttle back. So at this point, let's see if we can actually have a quick example.
Absolutely. Quick stretch break. I know you guys are like, seats are not comfortable, so if you want to move the shoulders or like stretch back a bit, take a little break. We're gonna do an example of how to use Cloud Save to basically take the data from the mobile phone. So like, I finished the jog, I have the track on my phone. I want the same track to be saved on my Cloud Save backend so that when I come back home, I pick up my tablet and I see the same track there. All right, so let's see how can we do this. So here's a class in Android Studio. There it is, called storage adapter. And basically this class, Walkshare app was using this class to save data on the local storage. So it has 3 methods: save to storage, read trails from storage, read waypoint from storage. What we've done is we've blown away the local storage code, and we added Cloud Save Manager calls. So we take the Google API client, which is generated by Android Studio, and entities that we want to save, and we pass it to Google Cloud Save Manager.save call. Similarly, to get trails from storage, we form the query using the stuff that Jatin just described in the slides, and we call Cloud Save Manager.query. It's as simple as that. So let me actually run this app on the phone and see what happens. I know this is a bit of like electromagnetic storm in the building, so fingers crossed. OK, so the bits are flying across the USB cable from the laptop to the phone, and there we go. OK, so just to show you the history tab, there's a single track in the history, and this is actually from earlier today. And if I start the tracking, OK, tracking first time, stop the tracking, switch back to the history tab, woohoo, 2 tracks. So to prove you guys that this is not like magic and trickery, let me switch to a Cloud Datastore. And here's the list of all the entities in the Datastore. Right now, there's nothing. So I refresh the query, woo, 2 tracks. Thank you very much. And one final kind of clap opportunity is, Jatin, if you refresh your tablet, let's see if we can get the same tracks on your tablet.
So we kept the tablet clean. We didn't refresh anything. So now we're going to refresh it. It's empty right now. Refresh, go back to the thing, come back to the history. Oh, nice. There it is.
All right. Thanks so much, guys. You're very generous with the clapping. So let me just super quickly summarize what we've seen so far. So you've seen that all of the code that I touched in Android Studio was client-side code, so no backend programming was involved. We still had access to the data using Cloud Datastore. And as Jatin described earlier, Cloud Save comes with really good online and offline scenario support, so things like conflict resolution, background synchronization, knowledge whether you're on cellular connection or Wi-Fi, and so on. So today, we're excited to open Cloud Save via early access program to a limited set of initial users. If you want to help us to make Cloud Save for Android even better, please use the link above to sign up. We're very much interested in hearing your feedback and suggestions on how we could improve Cloud Save even further before we release it to a wider audience. And if you want to get more information about Cloud Endpoints, which we've shown in the first half of the session, we've put together an end-to-end backend code lab, which you can just take it at your own pace when you go back home. And if you want to take your idea even beyond the free tier that Cloud Endpoints provide, go to g.co/cloudstarterpack and enter promo code GoogleIO to get $500 credit for Google Cloud Platform. All right, so that's all we had. Thank you very much, and we're going to open the floor for questions.
Yeah, can you bring the previous slide back?
Absolutely. The one with $500 or? Okay. We still have a few phones up, so going 4.
While you
going
take that
3.
picture, I'll take a picture of you.
Going 2. Going 1. Still a few folks. Sorry. Good for eyes, not amazing for cell phones. All right. For those of you who are still trying to get the picture, these slides will be posted when the talk is published and recorded, so you'll have the opportunity there as well. All right, and the $500 slide, there it is. OK, yes, a question.
So 2 questions.
Sure.
One is, how would you support sharing data across multiple users? And then 2 is, what about sharing on non-Android devices?
Mm-hmm.
So basically, the sharing across multiple users is not there yet. It will probably be a feature in the future, but it's not present right now.
Yeah. Having said that, the data is stored in the Cloud Datastore. So if you're using the first half of the session, if you're using Cloud Endpoints, then you can basically expose an endpoint which uses basically data store operations via App Engine backend, and you can just expose data that way. Yeah. And then second question was support for non-Android devices.
Right.
So good news is that it's on our radar. Bad news is that I cannot give you the exact date at this point.
I was wondering, is there any listeners for when the sync happens?
Is there any listeners? Yes. So there is basically an API called onRemoteChanged within the base event service, and it lets you know as soon as an entity changes, and it gives you a list of entities that changed.
Yeah, sorry, I was unfair to that side. 2 questions from that side now.
Okay, the form on the sign-up page is not publicly shared.
Oh, that's a bummer. Okay, let me.
Is there a form we can fill out to get it shared to us?
Yes, basically, as soon as I leave the podium, okay. I'll take care of that. Thank you very much. Sorry, one more question.
Is there a way to purge local data and then later restore it, so you don't fill up locally, so to say?
Is there a way to
purge
local data? So we do cache everything locally. So not yet, because we want your app to be able to run online as well as offline. So as soon as a user doesn't have data connection, they should be able to use the app still. So that is the goal of this service.
Okay, thanks.
Mm-hmm.
Okay, that's it.
So I know how to use the data store, and I know it has some quirks, especially around indexing. If you want to query on 2 properties at the same time, you have to generate a double index. How do you guys handle that automatically?
So on the backend, is your question about the Android or you running Android?
Well, with the Cloud Save, if I'm querying on
right.
2 properties, how how are you going to handle that?
So we don't have the same constraints as App Engine does. We don't have to go through a huge amount of data. It's just one user's data for one app. So we can easily, smartly do filtering inside the data. So it's not a huge amount of data we have to go through. So we can do it.
So you filter in memory?
Yeah.
Okay, thanks.
What's the storage mechanism on the client side? Is it file-based or SQLite-based?
It's SQLite-based.
Okay, so, and you guys handle completely the CRUD on that?
Yes. Sorry, we handle completely what on it?
The CRUD, create, read, update, delete?
Yes.
So do we, for Android Cloud Store, does that start out free and you just pay for App Engine when you start adding more logic and other access to the cloud, or is that always kind of a subscription thing?
You mean a cloud save?
Yeah, sorry.
Yeah, so basically, when you join the early access program, we're going to give you free quota for every user of your every app. Having said that, one of the reasons why we're trying it out first as an early access program is to figure out what that quota limit should be when we roll it out to a wider audience.
So it'll always be kind of a free small data quota and then you just pay for heavy use apps?
So at this moment, the details are not finalized in terms of how this is going to be handled. At the moment, for early access program, yes, but we're trying to make sure what makes most sense and kind of what's best for you guys.
Thank you.
And then 2 questions. Is the Google Cloud storage built on top of the endpoints? And are the endpoints, is there like a JavaScript interface? Like when you compile that API method, is it a REST interface or is there any library that?
Yeah. Yes and yes, basically. So endpoints have JavaScript client libraries, which get generated and kind of strongly, well, they're tailored to those annotations which you provide. So from those annotations, you can generate iOS client libraries, Android client libraries. That's basically what we've seen in the demo. And then JavaScript. I don't know if you remember, it was like a relatively fine point. When the web UI was generated automatically, like for enter the name, press hello button, and then there was hi IO session at the top. That was basically calling the JavaScript client libraries, which were generated for that particular backend.
Right.
And then yeah, regarding the second question, yes, it automatically generates a RESTful API from those annotations. And so if you basically want to call that using some other things, you'd have to parse the JSON objects and things like that, but you still have full access to it.
To answer your first question, the Cloud Safe, it uses a special API, which we created for doing a more optimized sync.
Okay. So it wouldn't have, you couldn't use these other access methods to work with Cloud Safe?
We could have. We just have other infrastructure inside, so.
Okay.
Yeah.
For larger assets like JPEGs and stuff, I have lots of those. I should use this for the metadata and something else for those?
Correct. And a good place to do that would be using Google Cloud Storage, so the big object storage. And then expose an endpoint using the kind of the first half of the session, expose the endpoint, which just transmits the JPEG.
Thank you.
Yeah.
So it looks like you guys support some spatial queries, so like proximity, but can you give more details, like what other kinds? So, like bounds or polygons?
Yeah, so if I understand the question correctly, it relates to how did we put the marker close to the location?
No, so for example, like I can store points, right, lat longs, and then
Correct.
I could say, hey, can you grab me the nearest, like within 10-mile radius, like all of the points?
Yeah, so what we've done there, it's actually a custom backend code, so you can literally do whatever you want. For this actual demo, we just generated the point kind of randomly within the radius. So don't tell that to anyone. No, I'm kidding. Like you'll see in the code, like if you watch the recording, it was just generated kind of randomly within like a mile radius around the current location.
Oh, so you cannot store geometry points on the database?
You totally can. Yeah, you totally can. It's just we didn't use it for the session.
All right, thanks.
Yeah. All right, one last question.
So for the L developer preview, they introduced it seemed like a new life cycle to optimize battery use. Is this plugged into some of the things from Project Volta, or are you guys using sync adapters kind of like in the old way?
So right now we use sync adapters, and we do plan to use, we do actually use the new, it's called task scheduler, GCM task scheduler, network scheduler, I think. We do use that for certain things which need us to delay a sync in the future.
Okay. Will this shift over to the Volta approach going forward?
Depends. So when we need to write, we would like to write as soon as the network is up, right? So we would use the Volta approach for it. But when we need to sync, based on the remote notifications, we already have the network up because we just received a notification. We just need to do a sync at that point. So then it will use a sync manager.
Thank you.
All right, cool. Thanks, guys.